is a continuation of the weather review that we've been talking about. We need to consider now our more severe weather event, which is typically some kind of a thunderstorm or thunderstorm related weather phenomena. We will talk about fog and some reduced visibilities as we go along, but we'll start with the thunderstorm. Great picture here. Glance through it, think about it. 3 things are necessary for a thunderstorm to form. We must have moisture, you got to have sufficient moisture for the clouds to form in the beginning. Then you have to have some kind of a lift. It could be convection, that's uneven heating of the Earth's surface. It could be a frontal movement where a cold front, or even a warm front, but most likely a cold front, pushes air up, starting this process of rising movement. Or it might be mechanical lifting, like a mountain range or something like that, where a nice breeze is blowing this warm, moist air up into the atmosphere. And if the air is unstable, of course, you remember now, in general, as you increase in altitude, the air temperature cools, at least up to the top of the troposphere. Of course, around fronts or mountains or near the ground, that's not always the case. Sometimes air will still stay warmer, and that's instability. If the air remains warmer than the surrounding air, it will continue to rise into something like this, a thunderstorm. How fast air cools is a measure of atmospheric stability. In other words, if the air cools fairly quickly, then it gets equilibrium and it doesn't rise any further. But if not, it continues to rise. Meteorologists refer to this vertical change in temperature as the lapse rate. So unless there's some sort of extreme, the temperature generally decreases between 2.7 degrees Fahrenheit and 5.4 degrees Fahrenheit per 1,000 feet. If the actual air cools slower than the lapse rate, the air remains relatively warm compared to this surrounding air mass, and it continues to rise and may develop, and that's instability, and may develop into a thunderstorm. That makes sense. So we have a typical question. Which weather phenomenon is always associated with a thunderstorm? Heavy rain, yeah, that's true. Hail, not always. But lightning is absolutely true. It may not be heavy rain, because they're mild thunderstorms, but you must have lightning, according to the FAA. Okay, here's another one. What type of weather phenomena may concern a remote pilot is common among cold fronts, thunderstorms, and heavy rain? Like I said, cold fronts is typically rapidly moving air mass because it's colder and denser than the warm air around it. It will be pushing this warm air up faster, and the faster makes it more or less stable and pushes the air up and turns into a thunderstorm. Okay, here's another question. Which is considered to be the most hazardous condition when flying a UAS in the vicinity of a thunderstorm? It is, in fact, lightning. There is actually two considerations here. A lightning strike can cause damage of the aircraft, but also it can interrupt the electronics. Well, I guess there's a third. You could get struck by lightning, so that might be considered. But lightning is the answer to the question. Here's another question that brings up a whole other issue that we need to talk about. If there is thunderstorm activity in the vicinity of an airport at which you plan to land, which hazardous atmospheric phenomena might be expected during recovery and landing of the unmanned aircraft system? And A is incorrect because precipitation static is not considered a hazardous atmospheric phenomena. C is incorrect because showery precipitation is not characteristic of a thunderstorm activity. So it's B, wind shear. And wind shear, that's that invisible hazard associated with all thunderstorms. Shear turbulence has been encountered up to 20 miles away from a severe storm. So in the vicinity of an airport at which you plan to land, which hazardous atmospheric phenomenon might be expected during recovering landing? Yeah, wind shear would be the answer to that question. All right, remember this diagram? We've looked at this before, the pictogram here. Thunderstorms, generally, thunderstorms only live for less than an hour, individual cells. Although there are supercell thunderstorms that may live for several hours. The thunderstorm may live for 1 hour, but the conditions necessary for a thunderstorm also may produce thunderstorms that pop up one after the other. So there's 3 stages in thunderstorms. The very first stage, cumulus stage, exists of just continuous updrafts, right? So we have uneven heating of the earth. This rising parcel of air rises up till it comes to the saturation point and it forms a cloud. If the air is unstable, it may continue to be warmer than the surrounding air and continue to rise, but at that point it's all rising air. Then we have the mature stage, which comes next when the top of the cloud reaches the point where rain begins. It has these updrafts and downdrafts. So precipitation, the mature stage, begins when precipitation begins to fall from the cloud. And when that happens, we have downdrafts developing, and the cell has entered a mature stage. So during that stage, lots of wind shear and turbulence is common, right? Because we have these opposing air winds, one going up, one going down, right? So we have wind shear and turbulence. Then we have the dissipating stage, which is the last stage. Predominantly, we're going to see downdrafts and rain, lots of rain. Still dangerous because you have the possibility of wind shear, still the possibility of wind shear and turbulence. And you also have the possibility of microbursts, which we'll talk about in a minute. A few questions. Okay, here's a question to think about. During the life cycle of a thunderstorm, which stage is characterized predominantly by downdrafts? The cumulus stage is updrafts mostly. The mature stage is updrafts and downdrafts. So B would be the third stage. As the thunderstorm is dying, it's dissipating. All right, let's talk about squall line thunderstorms just briefly. A squall line is a non-frontal, narrow band of thunderstorms that sometimes form along or ahead of a front. The line may be too long to get around for manned aircraft, and or if you had a fixed-wing drone and you're trying to get on the other side of the line, you probably couldn't make it. You just have to wait till it passes by. It often contains severe thunderstorms and tornadoes, etc. It's really the single most intense weather hazard that we're likely to encounter. So squall lines occur at all different altitudes. You can't fly over them or really under them. They're not unique to either high or low altitude operations. But they're fast moving, so you just wait on the ground until it goes by. It's dangerous weather, serious weather. So we have a question about squall lines. Squall lines, that, like I said, that narrow band. So when you read a question that says narrow band of active thunderstorms, you should spring to your mind, squall lines. We know about those, right? There are such things as dry lines and prefrontal systems, but this is a squall line question. Where are squalls most likely to form? At any altitude. Not high, not low, both of them. At any altitude they may form. Think about the question. Convective segments. Sort of goes to a previous lesson, but it has to do with thunderstorms. So we'll review this again. Convective segment, when they're issued, it's a type of forecast weather, significant meteorological weather. It's a warning to all pilots, small aircraft, big aircraft, drone pilots included, to tell you certain hazardous weather conditions are likely, like turbulence, icing, severe icing, low-level wind shear, surface winds greater than 50 knots of wind. Wow, that's pretty windy. Or hail at the surface greater than or equal to 3/4 of an inch. This is big chunks of ice. Tornadoes, thunderstorms, lines of thunderstorms. And that's what the answer here is. Lines of thunderstorm. They come close by saying surface winds greater than 40 knots. That sounds right. Nope, 50 knots. And visibility less than 3 miles? No, that would be an airmet. That's something totally different. All right, so now we look at microburst. A great pictorial here tells you more than I can say, probably, but if you look at it. But microburst is basically a localized column of sinking air, of downdraft, basically, within a thunderstorm, and usually less than or equal to about 2.5 miles in diameter when it hits the ground. Microburst can cause extensive damage. We've seen that in the Griffin area, even where a ring of trees are blown down because of a microburst. And they can be life-threatening, of course. Individual microbursts seldom last longer than about 15 minutes from the time that it hits the ground until it sort of dissipates. It's fairly short-lived. However, there may be multiple microbursts in a particular area, so and quite likely if it's a strong thunderstorm. But the thunderstorm may only last an hour, so that's something to consider as well. But like I said, thunderstorms can, if the conditions are right, thunderstorms, one will form right after the other one. So here's a question about that. What's the expected duration of an individual microburst? Well, I just said that, but still, you should know this. They'll seldom longer than 15 minutes from the time the burst strikes the ground until it dissipates. Lightning. Just something to consider. There's a double hazard here for lightning. Lightning, actually, there's triple hazard here. It can damage your sensitive electronics if it hits your drone. It might also cause some kind of structural damage. Typically in a manned aircraft, it'll punch holes in it. Doesn't make the manned aircraft don't crash because of lightning. They may crash because of loss of the electrical system, but typically it just puts holes in it. Well, but the drone is a lot smaller, so putting a couple holes in the drone could be damaging. The third reason it's hazardous, of course, is lightning strikes. Getting hit when you're standing outside in the field flying your drone around. Remember that lightning can strike good ways away from the actual thunderstorm, so be cautious about that. Many golfers know. Hail is another issue that we should just briefly mention. As you can see in this diagram, hail is falling on my head, apparently. No, the point of the diagram is that it's quite a ways away from, it can fall quite a ways away from the actual thunderstorm. So you can be in the clear skies. If there's a thunderstorm nearby, you might be pelted by balls of frozen precipitation. And of course, if they hit your drone, that'd be bad too. But just be aware of the danger that hail may present. All right, ceiling invisibility is another issue that will occasionally come up. Usually it's on the other session we did about reading the weather reports, but still the definition is important. For aviation purposes, a ceiling is the lowest layer of clouds reported as being broken or overcast. Clouds are reported as broken when most 5/8 to 7/8 of the sky is covered with clouds. Overcast simply means that the entire sky is covered with clouds. And those are the things that are reported in the METARs. Visibility is closely related to cloud cover, and reported visibility refers to the greatest horizontal distance that you can see out at which some prominent object can be viewed with the naked eye. Current visibilities are reported in the METAR reports and other weather reports, as well as by automated weather systems as well. So I think I've covered pretty much all of the material that will you'll most likely see in your written test. Like I've said before, give me a call if there's something you don't understand as you go through these practice tests. I am using them to score you for the course to obtain your technical certificate, but as well as that, doing them will help you to pass the FAA written test when you come around to doing that, of course. Remember to read through again for this section on weather, Chapter 3 of the FAA publication Small Unmanned Aircraft Systems Study Guide. You can download those from the FAA.gov website. Freely available, and it's got pretty much the same information that I've been giving you here. If you don't like people talking and you like reading better, that's the better resource. If you like to do both, which many people do, then you've got that. If you just want to hear me talk, you might be careful about that, because I didn't say anything untrue, I hope, but certainly there's more information in the written documents. Thank you.